Next topic 2.5 graphical representation of motion along a straight line. The next topic is graphical representation of motion along a straight line. Plotting the distance or displacement or speed or velocity on a graph help us to understand certain things about time and position. In a graph, we are going to plot the distance and speed. So this will help us to understand about the time and position. First, let us discuss about the distance time graph for uniform motion. First, let us discuss about the distance time graph for uniform motion. See here. First, let us plot some values on the graph. See here the distance time graph for uniform motion. Time in minutes, distance in meter we are calculating. So the time is for 0 minute 0 meter. Then for 5 minutes 500 meter. So 10 minutes means 500 into 2 1000 meter. Next for 15 minutes 1500. 20 minutes 2000 meter. 25 minutes 2500 meter. Likewise, the time is also getting increasing, the distance is also getting increasing. Now we are going to plot all these values in graph. See here, x-axis we will taken as time. Time is taken as x-axis and the distance is taken as y-axis. So see here, the time is of 0, 5, 10, 20, it is increasing 5, 5. So we are marking the values as 0, 5, 10, 15, 20, 25. Okay, wow. Next is distance. Distance is, it is increasing 500, 500. So see here, the distance of 1000 minus 500 is 500. 1500 minus 1000 is 500. So we are marking as 500, 1000, 1500, 2000 and 2500. Now we are going to plot the points. See here, 0 to 0. Next is 500. We are plotting the point here. Next is 10 2000. Likewise, while we are plotting, we are getting a straight line. We are getting a straight line. Next is, we are going to find a slope for it. So a graph is a straight ray. A person walked at a constant speed. If the graph is coming in straight line means a person is walking at a constant speed. In this graph, we notice that person covers equal distance in equal intervals of time. Because time is 5 minutes, it is getting differing. Here it is 500 meter. So what is that? A person covers equal distance in equal intervals of time. We can therefore conclude that he walked at a constant speed. So the person is walking at a constant speed. Next is speed is equal to distance travelled by time taken. Now we are going to find the slope in our graph. We are going to find the slope in our graph. See here. Slope is equal to y-axis by x-axis. Slope means we have to take which 2 points? We have to take any 2 points. The 2 points joining point we will take as slope. We are taking these two. These 2 points is joining here and these points are joining here. This triangle we are taking as slope. And we are marking as A, B and C. Okay, wow. So what is the formula? Slope is equal to y-axis by x-axis. Slope is equal to y-axis by x-axis. In y-axis, what is the value? BC. In x-axis, AC. So what is BC? BC is 500 meter. In y-axis, it is getting differ with the 500. 1000 minus 500, 2500 minus 500. So y-axis, we are marking the unit in the difference of 500 meter. So BC we are substituting 500 meter. In x-axis we are marking the unit with the difference of 5 minutes. So we are dividing both. We are dividing 500 by 5. When we are dividing, this is 1 time and this is 100 time. So it is a slope is equal to 100 meter per minute. Slope is equal to 100 meter per minute. To find slope, we have to take any 2 points. The 2 points joining place we will consider as slope. We have to plot as A, B and C. So slope is equal to y-axis by x-axis. Here y-axis is BC. So we are taking this. X-axis is AC. We are taking this. So finally the slope is 100 meter per minute. 100 meter per minute. Now see here. Let us take a look at the distance time graphs of three different people. See here, Asher walking. One person is walking and Safira cycling and Kanishka going in a car. Okay, but three persons are totally. One is walking, another one is cycling and another one is riding. Okay, we know that cycling can be faster than walking and a car can go faster than a cycling. See here, walking is faster than a cycling is faster than riding. So the distance time graph of the three would be in the given graph. See here, the distance is showed in graph. Next, the slope of the line on the distance, the time graph becomes steeper and steeper as the speed increases. See here, one is for walking, another one is cycling, another one is riding. To find the slope, we have to take any points. We are taking this as 20 kilometer. We are considering the minutes in, we are considering the time in hours 1 2 3 4 5 and we are taking the distance in 20 40 60 kilometer. So we are going to find the slope. See here, to find slope we have to take any 2 point joining point. So we are taking this. What they are saying is steeper the slope, greater is the speed. So the slope is greater to the speed. Speed is constant, so it is called as unaccelerated motion. So in the distance time graph, the speed is constant, so it is called as unaccelerated motion. Here the speed is getting increasing, so it is called as unaccelerated motion. Now let us see the distance time graph of non-uniform motion. Look at the points. The points given as 0 second, time we are taking as second and distance we are taking as meter. For 0 second it is traveling 0 meter and for 2 second the distance travelled is 1 meter and for 4 second it is traveling 4 meter, 6 second it is traveling 9, 10, 16, 10, 25, next for 12 is 36. Finally see here, it is having equal intervals of time, but the distance is unequal. So it is non-uniform motion. What is non-uniform motion? In equal intervals of time, if an object covers unequal distance in equal intervals of time. So here the distances are unequal. 4 minus 1 is 3, 9 minus 4 is 5. So the distances are unequal, but the time is equal. An object covers unequal distance in equal interval of time is said to be as non-uniform motion. So now let us plot the graph. We are taking as x-axis and y-axis. X-axis we are denoting time second and y-axis distance meter. So we are keeping two values. We are keeping for one box 2 units. 2, 4, 6, 8, 10, 12. Next is here 5, 10, 15, 20, 25, 30 and 35. Now we are plotting the points. See here, whether in uniform motion the graph grows in a straight line. Whether in non-uniform motion it is moving in a straight line? No, the graph is not going in a straight line. It is not a straight line. The distance time graph is non-uniform motion. So the nature of the graph shows non-linear variation. Here the graph is in non-uniform motion. The non-uniform motion means the distance covers unequal distances in equal intervals of time. That is said to be as non-uniform motion. So the nature of the graph shows non-linear variations of the distance travelled. The graph represents motion with non-uniform speed. The graph represents motion with non-uniform speed because the speed is not constant. Its distance is varying, so the speed is not constant. Are you clear?